students. Today is the 9th lecture. Today we are going to discuss the different irrigation system that is used in greenhouse. Though title is the greenhouse, but you know that in protected cultivation, other types of structure are also there, shade net structure, insect proof net, and other in any structure, right? But basically, what today we are discussing, that is types of irrigation normally used in the protected cultivation condition, right? So before going to the different type of irrigation system that is used in the protected cultivation, or you can say the greenhouse, first we should know what is the crop water need. You know very well, I think in your agriculture courses you have read about the evapotranspiration. So basically you can say that the crop water needs is depth of water needed to meet the water loss through evapotranspiration. And basically there are two terms. One is the conjunctive. There are many terms are there, but today we are, so there is another term that is conjunctive use. So basically what is conjunctive use? It is the sum of evapotranspiration plus the quantity of water used for metabolic activity. And basically if you see the major part that means the actual water that is used in the conjunctive means the metabolic activity, that is 1% of the total water used, right? So normally interchangeably we use the evapotranspiration and conjunctive use like in a same breath. You know already know what is evapotranspiration. Evapotranspiration is made of two terms, evaporation and transpiration. Evaporation you already know, it is loss of water from the soil surface, and the transpiration is the loss of water from the crop, you can say the crop's surface, right, leaf surface, and that is the free moisture that is available on your crop. And it can be expressed in different way. Basically if like the millimeter per unit time, it can be millimeter, can be maybe you can change in different unit, okay, and the time can be maybe day, hour, something like that, okay. So time can be, you can express time in different unit also. So it is clear from this picture that already we discussed that the basically evapotranspiration is made of two terms, evaporation and transpiration. So you know that the water loss from your open water source, soil, leaves and the stems of the plant, that is free moisture. And then another is the plant your transpiration. So basically it takes the water from your root zone, and so overall your evapotranspiration is the sum of evaporation and transpiration. And there are the various factors. So briefly we have classified in three way. First one is the weather parameter. In weather parameter, the important ones are radiation, air temperature, humidity and wind speed. And each one has, just for example, if your humidity is very high, so your vapor pressure difference will be very less, so water loss will be less. Like for example, if you see in Ranchi, we have the low humidity, low RH you can say. So means in Ranchi the RH is low, means the water loss will be more. But if you go to in same condition, you grow the crop in Dhanbad, the water loss will be less, because there the air is moist, right? And wind speed also, you know, because if wind is flowing, so your saturated air will, the air that water that is lost from your crop surface or soil, that will taken away by your air and wind speed, and so dry air will again come. So these are the factor, air temperature also like that, and radiation play the role in overall your affecting the evapotranspiration. Apart from that, the crop factor is also important. Which type of crop you are talking, means it is tomato or brinjal, depending on type of crop. Even in same crop the variety also matters. And apart from development stage, certainly it is very clear that each stage of development of crop, your crop water requirement and management practices and environmental condition, means the what is your soil fertility condition, what is the application of fertilizer, what is the condition of soil. There are various factors that comes under management environmental condition that affect the overall your evapotranspiration. So basically these are the three factors that affect your evapotranspiration. In evapotranspiration there are various concepts are there, but briefly today we will discuss the reference crop evapotranspiration. What is reference crop evapotranspiration? It is the climatic parameter expressing the evaporation power of atmosphere. The four factors we discussed just now, like the radiation, air temperature, humidity and wind speed. So this is the, basically you are expressing the evaporation power of climatic parameter, right? And the crop evapotranspiration under stated condition, that is crop water requirement. It is what is this? ETC. It refers to the evapotranspiration from the excellently managed large well water, means the in actual condition, if the what is the requirement of crop, like take the example of tomato. If you are growing tomato in and in the all the conditions are well managed, all the conditions are normal, means properly soil is in good condition, fertilizer, water, all microclimate. So in that condition, what is the your water requirement? That is your crop water requirement, already we discussed. And then the crop evapotranspiration under non-standard condition, means the if your growing condition is not optimal, in that condition what is your crop water requirement? That is the crop evapotranspiration under non-standard condition due to suboptimal crop management or environmental constraint that affect the crop growth and limit the evapotranspiration. Certainly, as we discussed, there are various factors. So if you're cultivating the crop that is not in normal condition, in that case your crop evapotranspiration means the crop water requirement will be under non-standard condition. So it is clear from here. So ET0 is the reference crop evapotranspiration. That is basically basically we used to know what is the climatic power, means what is the microclimate there, and the value of the ET0, because you know that the government of India at different locations the weather parameter is there. So by using the weather parameter, different softwares are there, you can calculate your ET0, right? And that there are different methods are there, like the experimental, like the by pan evaporation, or by various equations are there. By that you can calculate at any location, you can calculate. Like in our in our campus we have the weather station. From there we can take the data of the radiation, temperature, wind speed, humidity, and based on that we can calculate what is the your ET0 at the particular day. And that crop water requirement already we discussed that here we basically multiply with the your crop coefficient, and then you will able to know what is the crop. So it is ET0 multiplied by Kc factor, that is the that is your crop coefficient basically, and you will able to know what is the water requirement for that particular day. And then already we discussed, if you are growing the crop not under standard condition, that case we have to multiply by Ks, right? So in normal condition it is ETC0, but here ETC adjusted, means if your growing practices is not normal or environmental condition is not perfect, ideal, in that case we have to multiply, means multiply by Ks to know what is the actual water requirement. So this is crop water requirement. That this is one of the way you can able to calculate your crop water requirement. What is this? This is ETC is equal to Kc into ET0. You can, as I told, ET0 you can calculate by experimental method. By the pan evaporation is one of the common method, and apart from that the various formula are proposed by different scientists. So based on your weather parameter, you will able to calculate the ET0, and then Kc is the crop coefficient, and this is also vary from crop to crop, right? Each stage, right? And where we are growing, under drip it will different, under poly house it will different. So it is very interesting to know by using this formula you will able to calculate your crop water requirement. And here we have classified the types of watering systems. So basically there are 4 types. There are many other types are there, but briefly here I have classified in 4 ways. First one is the manual and hand watering. And second is the overhead irrigation system, surface irrigation system, and subsurface. So one by one we will discuss each one. Manual and hand watering, this is very common method. It is clear from the picture that this is very common. Suppose that if you are growing some nursery in the protected structure, not under, you can say, the poly house, maybe under poly house, but if it is a small structure, or maybe in bigger case, in some cases for watering, like for nursery, if you are going nursery, so normally we use by go by manual or hand watering. Other methods are also there. This is one of the method, but it is you can say most common but uneconomical, because it requires labor. And apart from that, you have to take care that, because when you are putting the water at the very high pressure, so your soil will spill come out from your pot or any place where you are taking the plant. So you have to take care of, so you have to reduce your speed of. So normally you know that fine rose spray, use some on the top of your here you can see you put, so basically in the form of rain, a small droplet, so the force will be less. So like that, this is the hand watering. Then the second one is the overhead irrigation system. In that, the first one is a sprinkler. This is very common irrigation system. Normally a sprinkler irrigation system is used in the close growing crops. In open also used, and in sometimes depending upon requirement which type of crops you are taking. Normally for growing the close growing crop, or you can say that the close growing crop, or you can say the nursery you are going for the fruit or flower or vegetables. In that case you can use the sprinkler irrigation system, and basically it is you know about the water comes in the form of small droplets, and therefore different type of nozzles are there, different perimeter is there, what will be its total area that will one sprinkler will cover. And basically in that, like in drip irrigation, you have to also take care about the quality of water, because if your quality of water is not good, it will block your nozzle. So there are various things that you have to take into count. And second one is the boom irrigation. This is the very common. What is the boom irrigation? Basically the same way like a sprinkler here, basically boom is there, and we you can see that here that one or more pipes containing nozzle that is apply water as the system moves on the plant basically, and the informative water is good, and various factors affect the selection, like the where you are, which crop you are taking, what is quality of water. So basically boom is the, you can see from the picture that it move horizontally, right? So suppose that you are growing a crop in the pot, in that case also you can use the boom irrigation, and the water application is very uniform here. And so this is one of the method. In case of a sprinkler, the method was, so it can be moved horizontally along your greenhouse structure. So it is you can say more automated in comparison to your manual system. Third one is the surface irrigation system. In that, the first one is the in drip. Basically we apply the control water at the very you can say the in control application of slow release of water, and localized irrigation means at the root, or maybe. So basically this is the drip irrigation, you can say this is one of the common method. And government of India, basically if you see in India in last, you can say in last 10 years, though it has started very long back, and Israel is one of the country that is master in the, you can say the long back they have started, other country also started, but drip irrigation is one of the, you can say the one of the hard very important irrigation system that required to change the to reduce the water loss, and to apply the water efficiency. There are many advantages we will see later on. So basically this is one of the important method to irrigate your crop. And basically in the greenhouse, like if you are taking vegetables or flowers, in that case normally you go with the drip irrigation system. So before going further, just there is comparison. You can see that this is comparison between surface method, sprinkler method, and drip method. You can see what is field capacity. Basically, your moisture content, that is freely available moisture content. That is what is the amount of water that is available between your wilting point and field capacity. So that is the moisture that is easily available to your plant. You can see in surface method what happens. Your moisture content changes very, because in surface irrigation what happens, today we irrigated, then after 10 days we will irrigate. So in first day it is over irrigated, and after with the time, because your less water will be available in the root zone, so crop will come under stress. So sprinkler irrigation is much better than you can say this from this picture. So this is the totally available readily available water and total available water. So basically the difference between the your field capacity and wilting point is the totally available water, and this is readily available. So in the total available water, the some amount is that is readily available, that is your readily available. And because the water available in your soil, all the water cannot be taken by the plant. So there are different types of water available in the soil, and you can see in drip there is less variation between the so you can see top one. So what happens normally in drip irrigation, we daily irrigate or after 1 day or 2 days. So your crop never come under stress, right? So based on evapotranspiration, daily evapotranspiration, basically we irrigate one daily or maybe 1 or 2, depending on which type of crop you are taking. And you can say in the drip irrigation there are 2 types of there: surface irrigation system, online drip irrigation system. the surface irrigation system is of two types, online drip irrigation system or inline drip irrigation system. And you can see on the online, basically the dripper, this is the lateral, on that your dripper is fixed. And in inline, basically your dripper is inside the pipe, right? And in subsurface drip irrigation system, basically your pipes go inside the soil. Okay, so this is the subsurface based on capillary movement of water. Water comes on, you irrigate the crop. And this is the diagram of your drip irrigation system. You can see there are various components as there. First one is certainly for growing the crop, you need water source. It may be, you can say, surface water or groundwater, and from there you take the water, and there different systems are there, different parts are there too. First we need the pump, okay? So based on your total power requirement to run the system, to run your last point up to dripper. So basically this is very simple calculation. You will be able to calculate how much, because if you are running the drip irrigation system, at each drip you require minimum pressure. So based on, because you are running the different type of filtration system, fertilizer system is there, okay, and different filtration systems are there. So and the water loss, friction loss is there. So basically we able to calculate what is the requirement of pump. So based on that we will select the pump, and different components are there. Here you can see that the bypass valve. So one by one later on we will discuss. So this is your main line, this is the sub main line, and this is the lateral. And on lateral, this is the end cap, right? And on the lateral we have the dripper. This is the picture shows the online dripper, right? And in, as I told, it is during the time of the manufacturing, the dripper is put inside your tube, right? And this is the flush valve on the sub main line. So different components we will discuss one by one. As I told, the water source can be, normally there are two types, surface water or you can say or groundwater. Surface water, if you see in the Jharkhand, normally use the, you can say river, farmers are using river stream, or open canal is not very common in the Jharkhand. Normally they are using the rainwater water that is available in the pond or well sometimes. Normally well or river stream or pond normally are using, and but these are the very common. So and in ground, groundwater, but you have to avoid the groundwater, because with the time the groundwater is going very low. So even if you see throughout the India, you are not getting the water for drinking. So basically here what I want to say, that you have to focus a lot on the rainwater harvesting. Already we have discussed in the earlier classes that by making the pond, you can harvest the rainwater in pond lining, and in pond lining, plastic lined pond, and then the same water can be used for irrigating your crops through drip or you can drip or a sprinkler system. So depending upon the water source, you have to take care what is the quality of water, which type of filtration we have to use. So you have to take care about based on your water source. As I told, that we have to, government of India and throughout the India, people, all the state government are focusing on the water source and basically in rainwater harvesting. So we have to take care that with the time we have to promote the rainwater harvesting system, so that the groundwater can be saved from, can be used at the important, can fulfill the important requirement of, you can say, drinking and other purposes. And pumps and pumping station, as I told earlier, that basically you required pump, because depending upon the water source from where we are pulling the water, so you required the different capacity of pump you can use. So based on your total power requirement, total energy requirement to fulfill because if you are running at each dripper, depending upon the discharge rate of your dripper, you require minimum pressure to give out the water through the dripper. So we can calculate the total power requirement, and based on that you can select the pump. Normally in gravitational, for Jharkhand like condition, you can use the gravitational, you can say gravitational pressure, like normally you can put the water tank at the 4 meter or 5 meter height, so that will give the pressure. Like in our house, the water tank is on top of house, and when the power is available, you fill the tank, and due to gravitational pressure you used to run our tap water, right? Same way in Jharkhand, some parts of Jharkhand, because in Jharkhand the small plot size is very small. For a small plot like the 20 decimal, like the 20 decimal up to 8,000 square meter, maybe up to 2,000 square meters. So farmers are still using in Jharkhand, but we have to promote. So basically, as I told, that to run the system, we required pressure, and apart from that, You know, the pump is very integral, that is very common. And certainly if you have the power pump, then you require power source, right? Then electricity can be one of the way to run the pump, and the diesel, gasoline. But the now government of India giving a lot of emphasis on the solar. Okay, you can say in coming time India will be solar capital of world, basically because you are using the fossil fuel. Now still you can say the NTPC is one of the largest producer of power, but they are using the coal to produce the power. NHPC, that is using the hydro power. But now from the last, you can say the 5-7 years, government of India is giving a lot of emphasis on the renewable source of energy, right? So what is the perfect way? That you harvest the rainwater, okay, and depending upon the requirement, if the water seepage is very high, then you can go to the plastic lining, and on that water harvested, rainwater harvested, so you have saved the water during rainy season, right? And then use the same water to irrigate your crop through micro irrigation, means the drip or sprinkler as per your crop. Okay, and to run that system, drip or sprinkler, you put the solar pump. This is very common one, and we are proposing maybe within the 6 to 1 year in our campus, this system will already pond lining system is there, but there some repair work is required. So we are in process to install to showcase the farmer or anyone that we have the rainwater harvesting pond and we have the solar pump, and the same pump is used to run your micro irrigation. This is one of the, because you are using the energy renewable source, and so what we are doing, basically you are harvesting the rainwater, okay, so you are saving the water, and then again using the water efficiently to irrigate your crops. And as I told in the picture, there are different components are there to efficiently. Basically our goal is to each point, means the water should reach all the point, and pressure and the flow of water should be uniform based on which type of dripper you have used. So there are different types of valves you are using. So the main purpose is controlling the pressure, flow and distribution under different condition. In that, the pressure relief valve is there whenever there is excessive pressure in your pipeline. So normally you use the bypass arrangement, or maybe pressure relief valve you normally use. Whenever there is excess pressure in your pipeline due to either static or surge pressure, so suppose that if your pump capacity is very high, right, and suppose that your pump is about 5 HP, right, and the power requirement of your system is 2 HP, right, then in that case, suppose that if the water pressure at the dripper will be maybe high, so maybe that your pipeline can be damaged. So in that case, we can use your bypass system. So bypass means you are releasing the pressure, right, whenever there is excess pressure in the system, because you know that each components run on a particular pressure, efficiently run the system. In that, there is a non-return valve. This is you can also say the non-return valve is this is non-return means the one way, means you can also use to say the check valve or non-return valve or one-way valve, means these valves are used to prevent unwanted flow reversal, means if the water is flowing in one direction due to some reason, maybe at a start or in the close time due to differential pressure difference, maybe if water flow in backward direction, then what will happen, especially your fertilizer can go into your water source. So normally use the non-return valve in the drip irrigation system, so that there should not be, if there is some time flow reversal, then fertilizer water should not go to your actual water source. And the ball valve this is normal valve to control the flow of your water. Then air release valve, air release vacuum breaker valve, it will provide a highest point in the main line to release the entrapped air. Sometimes there is at the start, or you can say at the start and the closing of the pump, maybe there is the build-up of your vacuum or air entrapped inside your pipeline. So for that, you normally use the air release valve, and you use the pressure gauge to know what is the pressure at each point. Like the infiltration, before the filtration, after filtration, what it will tell. Suppose that at the start of the filtration, means in the pipeline there is the filtration system is there, and before the water that is going into the filtration system, you will put the pressure gauge, and after the filtration. So with the time you can know that if there is a higher pressure drop between after water that is passing through your filtration system, you can know that there is need to clean the pressure your filtration system. So basically, to know what at each point how much pressure you are getting, so pressure gauge is very, as I told earlier also, that to run the system required, because all systems are like your dripper and the different pipes are designed for the different pressure, right? So to maintain the pressure, to check out what is the pressure at each point, and at the important point, basically at the filtration at the filtration or fertigation system, normally you put your pressure gauge to know what is the actual pressure you are getting at any point. As I told that there are various type of filtration based on their because see, whenever you are running your irrigation system, filtration is very essential depending upon the water source. Means that if it is groundwater, in that case maybe filtration system will be different, but if it is water's open source, in that case your filtration system will be different. So based on your quality of water, because why it is essential filtration, because if you will not properly filter the water, then it will choke out your dripper in your drip system, or sprinkler nozzle in the sprinkler system. So what will happen, the less water will come through your nozzle, or you can say dripper. So the actually, as per design, suppose that it is if dripper discharges 2 liters per hour, and if it is choke, so the plant will get less water, right? So and there are different types of regions are there, maybe chemical, physical or biological regions are there. Based on your quality of water, means which type of source you are using, and so you have to take care. So there are different types of filters are there based on your source of water and what is the different type, maybe physical, chemical or microbial, biological things that is in water. So based on your you can say, as I told, your quality of water, you have to use the required type of filtration system. These are you can say the hydrocyclone. This is also used to say centrifugal. Centrifugal filtration system. So based on centrifugal force. So normally for the higher particle, if the more sand and like that, the bigger particle is there. So based on that, you use the cyclone filter. And this is the sand filter. Normally used in some places, used for the, you can say. And this is the basically what you do. This is the sand filter. You pass the water through the bed of sand, and the various size of sands particle are there, and then at one end you pass the water through the sand filter, and from one end we take the filter water. Then this is a skin filter, normally like this is a skin filter, and there are various types of filters. The pore size is available, and based on your quality of water and your discharge, what is the design discharge, so you can select the screen filter, right? And the disc filter, basically here also, as I told, in this screen filter different pore size is there. Metal, it is made of metal or sometimes plastics. So various types of, whenever you will visit the department, we will show you we have all the component in the field and in our laboratory also. In museum, as I told, we have developed plasticulture technology information system. So I hope you will come soon to our campus, because due to COVID reason we are not here. So we will show in the field also. And this filter, this is here it works in 2 steps. First step, bigger particle is removed, and there is the you can say the in second step the smaller particle is filtered, right? So this is the 2-step process in the disc filter. So as I told, based on your quality of water, okay, and which type of dissolved particle is there, so you will select normally you use the sand filter followed by your screen filter. Okay, and so as I told, depending upon your actual water requirement and the quality of water, you will select the different type of filter, because whenever your water pass through this filter, then the pressure loss will be there. So size of pump will also depend upon how many filters you are using, right? So you have to take into account. Then you know very well that one of the advantage of the drip irrigation system is that with the drip irrigation system, because you are efficiently using the water, so apart from that you will able to use the same fertilizer. Here what is fertigation? Basically it is the application of water soluble fertilizer through your drip system, right? So you know that in drip irrigation system it is localized application of water. So with the same water we apply the nutrient, but in case of fertilization, normally you use the broadcasting, a lot of fertilizer loss is there, but in the fertigation you use the water soluble fertilizer, and this is one of the efficient way of application of fertilizer to the plants. And when as and when the different dose of fertilizer, depending upon your plant growth stage, you can apply the, you can give the water soluble fertilizer through the drip system. Just for comparison, you can see that in case of soil application broadcasting, and normally you are giving the without not water soluble fertilizer, then you can see the efficiency of nitrogen is the fertilizer use efficiency 30 to 50% and 95% in case of fertigation. This is a broad range data has been given. So what is the meaning of this? This means that suppose that if the nitrogen application use efficiency is 50%, means the 50% water fertilizer is going into drain, going into water body, or maybe evaporating. You know the nitrogen fertilizer, urea, that maybe evaporate or maybe go to your water body, and that water body again you are taking for drinking water. Okay. So nowadays, just recently you have maybe that you know that the nano fertilizer has come. So basically, you know that government of India giving a lot of subsidy on your nitrogenous fertilizer. Okay, fertilizer subsidy. So take the case of urea, a lot of subsidies is given in government of India, right? And what is happening here, fertilizer and all the normally all the fertilizer you're using for your broadcasting method. So what is happening? Basically, that you can say if the government of India is giving 50,000 crore of subsidy, 25,000 going into drain. That is not going into only drain. That is polluting your water body, okay, and air environment also. So this is very essential that you have to think that how to increase your fertilizer use efficiency. And like that, as I told, for giving the fertilizer to your plant, there are various methods are there, like the various system is the most common is the Venturi one, fertilizer tank and fertigation pump. Basically, to give the fertilizer to your plant, right, through the drip irrigation system. I explained. In Venturi, you know that in 12th class we have read that this is the Venturi system is there. So basically this is the pipeline, and due to suction, you close the throttle, and due to that the suction is created, and this is the tank, this is atmospheric pressure, and your fertilizer will go through this pipe, okay. And this is the less costly one, and this is very common technique to use your Venturi system. Fertilizer tank is the same way. We create the pressure. Here what you do in Venturi also, this is your fertilizer, a small bucket you can take, and there you can put your water soluble fertilizer into water, and then it will suck out. Like that, if fertilizer tank is there, here you will put your fertilizer, water soluble fertilizer in the tank, and this will do. Two pipes will attach to your pipeline, and then due to you use the valve to create the bypass, and then water will pass through this, and we can, based on your requirement, we can apply the fertilizer. Same way fertigation pump is there, and each one has its advantage and disadvantage. And then water distribution network is there. Already we have seen that in your drip irrigation system, main line, sub main line, and laterals are there. These are three main line, three important distribution network is available. Already I've shown in the picture, and based on there are different types of PVC pipe, or you can say SDP pipe, and different diameter, and each pipe is designed for different pressure. Okay, so this is PVC pipes, SDP pipes. Already we discussed online as I told you. This is the pipe, okay, and this is the drippers. Okay, online we put the dripper on the pipe, right, and you can say that your dripper is inside your pipe, right. This is end cap. Already I have shown in the picture. You can see from the picture. Basically, at the end of your lateral to close so water should not come from the lateral end. And this is the flush valve. It is flush out the water or dirt accumulated at the end of submain. So at the end of your submain, you used to sometime suppose that if some dirt has come, it should not come, but sometime we open to check out if there is some dirt is there, then you can open and it will come out from normally you put the end of your submain. And there are various advantages. Briefly, I have given the points. Water saving, this is very common one, because it required efficient technique. Depending upon which type of crop you are taking, which type of irrigation system is sprinkler or like that, so your water saving is minimum 30%, 25 to 30%. So water saving means if you are saving the water, basically you are increasing if you see throughout the India, everyone is talking about water. See, you are not getting the water for drinking. So what about the crop, taking the crop, right? So you have to think, because government of India through you can say various scheme is giving a lot of subsidy. Already we have discussed that for micro irrigation system a lot of subsidy, 50% subsidy is given in government of India. So water saving is one of the important. Apart from that, already we discussed that it increases the, if you are using water soluble fertilizer, it increases the, so fertilizer saving is also there, right? And apart from that, the reduce weed growth. Why? Because you are giving the localized water. In normally we give the flood irrigation, right? So all the, apart from the your plant root zone where water is required to, so that plant can take the water, you are irrigating all the soil, right? So what is, a lot of water loss is there, and then we have irrigated at the places there is no need. So certainly weed will grow. So these are the some of the advantage that has been listed out. And then the perimeter watering system is there. This is very common one. Normally in case of, you can say, fruit crop, this is lateral through that. Perimeter means, you know, around the circle. So normally for fruit crop, and the online dripper normally used for this type of system. So means the, you have to know the check basin, like the, normally you see in the at the root, because the tree has the bigger you can say a larger area of root development, right? Not like tomato and any vegetable crop. So area is larger, right? Trunk size is more. So here you use the perimeter, like in check basin you have seen in the case of fruits. Normally you make a perimeter, right? So in that case you give the water by manual. Here you are giving by the, you can your drip irrigation system. Then tube watering system is there, same like that. This is the surface irrigation system. So basically to irrigate your, if you are taking crop in the pots, for that the a small diameter like the 0.911, different types of micro tubes are there. In that the your dripper is put at the end, and then you can irrigate your pots. So this is the picture, and the last one is the subsurface irrigation system. This is one of the, you can say this is one of the efficient method of the, and depending on which type of crop you are taking, and at different location, depending upon your crop requirement, each one has, like the, for surface has some advantage, subsurface has some advantage, right? So basically how it is operating, you know very well. In subsurface what is happening, like the, you are irrigating the crops, right? So what happens, you know the capillary movement based on your adhesion, cohesion and surface tension, your water moves from your capillary space in the soil, right? Same the capillary movement. So basically water moves against the gravitational force, right? So subsurface irrigation system works on the capillary movement of your water. So here you can see that this is even flow system, how it operates. So basically you can see that you can see that it is used for potted and bedding plants, right? And you put the crop on the bench, and then and what happens, from one end you are giving the water, and there is the, you can say there is a hole in your pot below your in pot, and then water is passed through this table, and then it will take, due to capillary movement of, it will take the water, and after some time it will drain out the water from this table, right? And you can apply fertilizer also, right? So basically here you can apply the water, fertilizer, and to the mainly in potting plants normally use this type of system. As I told, capillary mat watering system here, basically capillary mat is made of absorbent material, so basically it absorbs the moisture, right? So essentially it is a wicking process where the mat wicks the water, and then the soil in the pot wicks the water from the plant, from the mat. Basically, as I told you, like this is the capillary mat, and you put your pot on this capillary mat, okay? And this is the, this has a capillary mat has water, okay? So you can see that normally it is a fully automated system, and you can say that the fill the water reservoir once or twice a week, and the plants get exactly what they, basically as I told you, like the capillary. So this is the capillary mat watering system. So your mat has a lot of moisture, water, and then your pot will take the through like the, because if the pot is dry, then it will take the moisture from the as and when required. So if the water potential difference is less, and your mat is at atmospheric pressure, so due to that your water movement will there, and your pot will take the like that. Flood irrigation, your floor flood irrigation system is same like that. On the floor you put the water, and this system can be used for, normally used for ornamental plant, okay, in pot, or normally for nursery raising nowadays also you are using. Basically on the floor you are giving the water, and like as I told you, the basic principle of subsurface irrigation system, your planting material will take the water, right? And the water tray and saucer, you know that this is the water. So basically, you know that on the pot there is the hole below your pot, and so like that, if you give them water here, so based on like the subsurface principle, subsurface irrigation principle, capillary movement, the water will take, and this is the very. So as I told, basically you can say that in summary, I can say that what are the important lessons today you have learned, that basically we have to think about the first, how to conserve the moisture, right? Earlier you discussed water harvesting, and then then based on the which type of, suppose that as I suggest that you should not use the groundwater, okay? So you go for rainwater harvesting, then use the micro irrigation system. But if you are using micro irrigation system, design of micro irrigation system is very essential. That is not very tough. So based on the crop spacing, which crop you are taking in, so based on your crop, your water requirement will be different, plant to plant, row to row spacing, what is there, right? And the different type of filtration system. So your filtration system will selected based on your total quality of water, right? And then the different type of fertigation system is there. You will use the different type of fertigation based on your requirement, because as I told, Venturi is one of the low cost, right? So if you will start with the Venturi, and normally the pump system used for higher area for more control, right? So and then as I told that you should use the solar system, right? Normally government of gives a lot of emphasis, giving a lot of 50% subsidy to install the solar pump. Government of India has fixed a target to replace all the electrical pump or diesel pump by solar pump. In Jharkhand also you can see, and to different parts of India, a lot of solar pump is coming in the farmers field, right? And then you have learnt about the surface, subsurface, and the different type. Basically, what is the basic purpose? Basic purpose is that your water should not be wasted, your fertilizer should not be wasted, your environment should not be polluted, maybe air or groundwater, right? So based on your crop, and if you're going for a fruit crop, right? Normally nowadays in fruit crop is also cultivated under protected cultivation, like banana, pomegranate, insect net, depending upon, because normally you used to cultivate the fruit crop in the open field, but nowadays in developed country, in some parts of India, research is going on. The fruit crop are cultivated in the insect net or shade net, they are to make the microclimate more suitable, right? In that case also, so based on, if you are going for nursery, any nursery, fruit, flower or vegetable, or you are going for food cultivation or vegetable cultivation, so based on that you will select the efficient irrigation system, and through that the fertilizer, so that fertilizer use efficiency can be enhanced, right? Like that. So this is all about today irrigation system. The title was the greenhouse, but this is the, you can say broadly, it is the under protected cultivation, okay? And thank you for your patience, and if I will be very happy if you have any question, then you can mail me, or you can discuss on the Google Meet, or this is my WhatsApp number, and a lot of material is there, because micro irrigation and sprinkler is the full-fledged course, 1 semester course. So briefly I have touched, but I will be happy if you have any question, I will be happy to reply those questions. Thank you for your patience. I hope today you have learned something new. Okay, thank you.